Want to start event? Okay, yes. Good morning, good afternoon, good evening, depending where you're connecting from. Welcome to our Smarter MFA using Risk Based Conditional Access webinar, where we're going to be talking about how you can use Risk Based Conditional Access to increase the smarts and the intelligence of our MFA technology, and also use Risk Based Conditional Access in the wider scenarios where Risk Based Conditional Access can be used. So today's seminar, I have to just take you through a very rough agenda of what we want to talk about today. Is first, I want to talk about what risk-based conditional access is, why we're doing this and what's involved in it, but also give you some understanding of the different components and how the system makes decisions. So I'm actually going to be sharing some things that are not very often shared. I'm going to briefly touch upon how we implement this on-prem. And then lastly, obviously, I have a demo where I'm going to take you through how you configure this, because it's one thing to give you a lot of slides, and I try to limit how many slides I give you and show you a little bit more what it looks like in a real live environment, because typically I personally find that a lot easier to understand what all this stuff is. So when we talk about risk-based conditional access, this fits into a larger umbrella technology that we call identity protection. And identity protection contains the two main items of identity protection is risk-based conditional access and Defender for Identity, which is what handles the on-prem situation. And to give you a little bit of a background why we build technologies and do these things and what the problem space is, to explain why this is important, let's give you a little bit of just a couple of statistics and a couple of information to get a bit of an understanding of what the risk environment is that we deal with nowadays. I mean, not so long ago, probably 2 weeks ago, during a presentation, somebody was mentioning, so like nowadays, every 7 seconds there's another attack. And I'm sorry to disappoint you, every 7 seconds is not how frequent there's an attack. Nowadays, we see on our environment more than 4,000 attempted attacks that we block per second. So that's quite a high number. But there's a couple of other interesting little tidbits of information, and this is all information that comes out of our own research. So we publish a report every year with that research, but we also find that, for example, in almost 90% of the cases, that attacks involved unmanaged devices. So if you are licensed for Intune and you're licensed for Defender for Endpoint, for example, deploy those technologies because they have a very real impact on reducing the risk to your environment. The other thing I mentioned there as well, 70% of organizations that have been compromised or that have been the subject of human operating ransomware attacks, we call those humor attacks for some reason, these organizations have less than 500 employees. So again, the idea that you are a smaller organization makes you less interesting to attackers. I'm sorry to burst your bubble. We see that smaller organizations, medium-sized organizations are as much at risk as larger organizations, but very often don't necessarily have all the same tools and same teams and professionals to protect themselves. And the last one, if you look at the top, and I find this quite an interesting statistics as well, is that 88% of the impacted organizations weren't following best practices, which leaves a lot of room for improvement, if you ask me. And it's typical when your company has been compromised, they always like to point to some zero-day security vulnerability or not a security vulnerability, but actually, in most cases, it's actually misconfiguration, missing configuration, etc. Now, it's very hard to get these things perfect. It's very hard not to miss anything, but as much as we can use the tools we have within all our products. So if you go into Defender, if you go into Entra Portal, there is something called a security score that will already alert you to a lot of things you can do better. And I strongly recommend you use those. Here are some more statistics just to scare you a little bit. You can see how much it costs to hire somebody to attack an organization. You can buy stolen usernames and passwords for about $1. You get 1,000 of them. You have specific attacks. You can buy denial of service. Basically, malware as a service is a real service that exists. They don't typically operate officially within places like Australia, but we do know in certain countries that these are very well established businesses, and in some cases even are allowed to operate with government support. So really don't think that you're not subject to this. But there's some good news as well. If you look at the left, we've noticed an increase in strong authentication. So authentication where MFA is involved. We've seen an increase in 220% there. A big part that has been driving that is that we've been enabling what we call security defaults and new tenants. So if you set up a new tenant, MFA will be enabled for admin accounts, for example, and customers have to turn that off if they don't want to use it. And we can see that 80% of the tenants that are being created, customers leave this turned on, which is good because we see that increases the protection that customers are implementing. Now, here's some other interesting information as well. This is a little graph of attack traffic, as we can observe it on our environment, and our Entra ID service is one of the largest SaaS services available. It is one of the largest identity service available. There's hundreds of millions of accounts on there, and so obviously we see a lot of traffic. And the interesting thing is we still see an increase in phishing traffic, but things like breach replace and password sprays are relatively speaking declining in importance. And that kind of suggests that a lot of the things we're doing are having a real impact. That's, of course, good news. Actually, and this is not in this graph, but we've also noticed that we kind of, when it comes to purely password compromises, that we're starting to see a little bit of a peak as well. So our push towards passwordless, etc., is starting to have a measurable impact in reducing the vulnerability for companies. Now, one of the things we always like to talk about when we talk about security is zero trust. And this is not a zero trust presentation, so I'm not going to go spend 10 minutes talking about zero trust, but I do want to rehash some of the key principles when we talk about zero trust. And there's three key principles that we adhere. And I know there's other organizations with a little bit different definition for these things, but ultimately they all come back to a similar type of concept. The first one is verify explicitly, and this is really where our identity protection and our conditional access policies, etc., come in. Verified explicitly basically means if a user or an identity, so this could be a workload identity, think of it as a service account, for example, if they need to access a piece of data, an application, infrastructure, network, etc., is that when that happens, we check whether they are permitted to do so. So, and we do this every time. And this is usually transparent to users, but if you check in the logs, if you enable auditing, for example, in an Entra ID tenant, you'll see there's actually a lot of messages, because for every application that you access as a user, typically, if it's not one of the first-party Microsoft ones, this would be checked every hour for each browser tab, for example, each application. So there's actually quite a lot of that checking going on. The second one, which is really the subject of our identity governance, which is not really what we're going to be talking about, but this is using least privilege access. This basically means that make sure that people can access what they need to access when they need to access for the right reasons. And if these things don't apply, they shouldn't have access in the first place. So we have, of course, a lot of identity governance products there that can help you do this. And then the last one is always the one that for some reason people find controversial. I don't know why, which is assume breach. The whole idea is there that don't think that your internal network is safe. Design everything and build everything with the idea that an attacker may already be in your system. And if you use that as a guideline, you will start seeing that you are not working with any assumptions anymore of, well, what is safe and what is not safe. You're basically going to treat everything as unsafe. And that is going to help you actually build a stronger and more resilient environment. Now, because we've been talking about identity protection and risk-based conditional access, just to put it in perspective, what do we consider risk-based conditional access? When we talk about conditional access, and I'll show you conditional access itself, it's basically where we set a set of conditions and a set of rules that control whether somebody or something can access a particular piece of data, application, etc. Now, risk-based conditional access is where then we add risk-based controls. And what is that driven by? And this is really what we're talking about here, is, for example, we have a lot of signals, and we put here, so like 65 trillion signals a day. To put it in perspective, that is 750 million signals a second. So that's quite a lot of data that gets processed every day, but that's not the only data. But that information is used then in to do things, for for example, to establish whether your travel is what we typically, when we talk about a typical travel is, for example, a user normally logs in for a country A and then suddenly they show up in country B. Now, that can be as expected, but it can also be something that is not expected. And so we'll get into a little bit more detail what that actually looks like and how these decisions are being made. And so all these conditions, rather than in typical conditional access, basically you have a fixed static set of rules, as in user A trying to access application B, and they're coming from that network. When we talk about risk-based conditional access, suddenly we have a condition that is the result of dynamic analysis of data, dynamic analysis and machine learning of an awful lot of signals, and that will make a decision whether or not you would allow that access. And so with risk-based conditional access, the decision could be different today as opposed to yesterday, for example. So it adjusts based on the situation. And that's quite a big leap from your traditional standard conditional access. Now, to implement this, I mean, very quickly, this is a very high-level overview. Obviously, if you want to use conditional access to protect your applications, you need to make sure that you connect your applications and use Entra ID to authenticate those applications. This will implement multi-factor authentication for those applications. It will implement particular conditions. You can then control in how you're going to allow access and what you may want to do, and enforce least privilege on this as well. So this is, again, a very typical slide. A version of this slide shows up in almost every slide deck that we use. And it's kind of, again, rehashing the same ID. You have Entra ID as a platform, sits at the center of this thing, where you have your user accounts come from Active Directory, may come from HR systems, etc. And we provide sign-in capability to cloud applications, but also on-premise applications through app proxy or third-party network delivery controllers, such as, say, in F5, Netscaler, etc. But so Entra is the controlling authority in this. Now, just very quickly, I want to touch upon multi-factor authentication in this as well. There's multiple different ways that you can use some multi-factor authentication methods. We are passwordless, such as Windows Hello, FIDO2 keys, biometrics, etc. Those ones will actually implement MFA while you're logging in. So if you sign in with Windows Hello, even though you may only be looking at your computer and pressing the spacebar to log in, actually you have met the threshold for MFA as well. Why? Because it involves something you are, something you have, and something you know, one of these things. And so typically the something you have would actually be the physical device that you're signing into, because it has keys installed on there. Also, some of these ones are phishing resistant. Now, there are some changes coming up. So passkeys, you know, the technology that is built on FIDO2 keys, but that has now been expanded partially through the support of Apple to do passkeys that can be synchronized. So that support is coming very soon. Microsoft Authenticator is also going to implement the use of passkeys to do phishing resistant sign-in in a passwordless fashion for Microsoft Authenticator as well. Now, all this basically takes me to the conditional access engine. And the conditional access engine really is this central component. And in a standard scenario, you would have a user trying to access a couple of applications. There's going to be a couple of conditions, and these conditions, and here I need to stress this again, when we talk about conditional access, conditions are the when condition. It is when this policy should take effect. The conditions are not the conditions that apply to whether you should be granted access or not. That is not the condition. This is the condition for when this policy takes effect. So that could be a policy that's specific based on a user, where they're coming from. They can use, for example, when we're talking about compliant or non-compliant devices, typically that ties into Microsoft Intune so that we get signals for that. It may use Defender for Endpoint, for example, to get information. So you'll have these type of additional signals that can be used as part of the conditions and the control. So you have multiple different type of conditions. So on the left is basically all about when, basically what kind of users or different ways. that people could be connecting. So these are all conditions. And then on the right, we have what we call controls. And the control is basically whether you're going to allow somebody to access or not. Seems to be the most standard type of control, but you have different type of controls where you may require MFA. You may force somebody to change their password. You could block particular authentication methods. And when it says, okay, limited access, basically we can force people to use Defender for Cloud Apps, where the traffic between your client and the application access is going through a separate piece of infrastructure that can implement policies on it and additional controls. So what you see right now here is your standard conditional access as it comes with P1 licensing. So if you have an E3 license, you have P1, etc., this is your standard conditional access. Now we're going to add the identity protection on top of it. And you can see that suddenly this engine that makes decisions based on the conditions suddenly has additional conditions which are a little bit less fixed. So this is where we have two different additional condition types that come in. One is called user risk and one is called session risk. And user risk is really the risk associated to user. And when you have this enabled, every user will have a risk score. And typically it gets classified low, medium, high. And based on that, a decision may be made whether user is allowed access or not. Similarly, you have session risk or sign-in risk. And this is more related to your activity when you're trying to sign in. So your sign-in risk is not associated to user, that's to you trying to access something, as opposed to user risk is almost something that follows you around across multiple different applications, etc. So we have a couple of different criteria there. So you have user leaked credentials. This is effectively when credentials get leaked on the internet. We actually load those into our system several times a day, and then we'll force users to change their password if they're actually matching those credentials. We may look at unfamiliar sign-in properties. So that uses the end user behavior analytics, for example. You have things like impossible or atypical travel. What is impossible travel? Well, for example, I log in right now. I'm in Australia, so I'm logging into my computer and I'm presenting to you. Now, if somebody in Italy is also logging in with my credentials at the same time, there's something fishy going on, obviously. We also have unusual user activity, or so one of the things to keep in mind here is that as part of us to establish, it's like, okay, how do I know the travel is not valid? How do I know this is not correct? Is we do have to create a baseline. And so one of the things that happens when you enable identity protection is that we're going to start creating a bit of a baseline per user about what is typical behavior for that user, so that we can establish saying, this has changed. This is not the same anymore. Now, all this stuff then has the added additional information. I was talking about the 65 trillion signals. We also have 130 terabytes of data that we process every day. It goes through machine learning. We have then threat intelligence. So threat intelligence is both a product you can subscribe to, but it's also a data feed into, for example, Sentinel, Defender, etc., where we have all this research we do around the organizations that are attacking companies, for example, the criminals on the internet, all that information, the IP addresses they're using, the techniques, etc., all that stuff starts feeding into here as well. This is what I mean by saying this is dynamic, in that how things are evaluated and what is dodgy and potentially problematic today could be different. There could be a trigger, for example, that we see on your domain, a password spray attack taking place. So somebody's actively targeting your organization. That could affect the risk ratios for your accounts in your organization. And let's give you a little of an example how this works in practice as well. So we have a user using a particular device trying to access a particular resource. And we can see basically we collect some information about that user. We can see in this case, it's a user part of a group called London Users. We can see that they're based in the UK. We can see where they usually sign in. We can see that they're on a Windows machine and that kind of stuff, right? And so in this situation, the conditional access risk would be considered low. So if we have policies that only kick in when medium or high are set as a requirement, then that policy would not apply, right? Now, let's say, for example, when we look a bit deeper and actually find that the user is using an anonymous browser, and you can see the risk already goes up. And then we find that the device is compromised. This is something that Defender for Endpoint, for example, can report. So suddenly we see information here that, hey, they're using an anonymous IP address. This user is coming from Asia, which if the user was signing in from the UK 5 hours ago, and now suddenly they're in Asia, you can't make it from the UK into Asia in 5 hours. I know from experience, it's at least about a 12 or 13-hour flight, so it's quite a long flight. So we see, based on this information, the system now said, this user, this looks very suspicious. And so the conditional access risk has been elevated to high. The result of that is that the access is blocked for this user, and the user has to remediate their access. And the typical ways, depending on the risk that is triggering this is done either by forcing a password change or by doing an additional MFA challenge, for example. And so how do we dynamically determine this level of compromise? So there's a couple of these here. Yeah, I have 5 of these items in the list, but the indicators, it's a much longer list. There's a whole list of them that are listed on our website, but there's also some that we don't necessarily share. We don't want to make it too easy for people to know how they can find ways around it. But you have each of these things. Say, for example, if we check, is this the normal time of day? That gives a little bit of weight. Is this a familiar device? Yes or no? If it's not a familiar device, that adds also a certain number of score to it. This is a little bit like the scoring system when you look at how spam emails get classified, for example. So if this is true, then you get a number 2. If this is true, then you add a little bit. And so each particular condition increases the potential risk score until you get a certain threshold. So normal time of the day on its own may not trigger a medium or high risk, but multiple combinations of things may. This is a little bit what you see in this particular slide here. You have this particular user, Claire, usually connects from the US. We can see the IP addresses that she typically comes from. We see the applications she typically accesses. We see the devices that she typically uses. And then we see suddenly, if you look at the 5th item in the list, so like, it seems to be very odd time, 2 a.m. in the morning. We see her connecting from a Linux machine on an IP address that actually we see is also associated with a whole bunch of other people. That's already suspicious. And we've never seen her log in from Italy. So there's suddenly a whole bunch of alarm bells going off. And that basically then triggers saying, like, this doesn't seem to be a genuine login. So we mark that as bad. Now, all these evaluations, keep in mind that when people get marked as, say, this is a risky user, for example, you then as an admin can say, okay, I can downgrade that stuff as again. And so the system does learn from this. So every time that we have a false positive, for example, it will adjust and update a little bit this baseline. And we say, well, it's normal that she does all these things. Then we start learning from that and say, okay, well, this is, in case of Claire, not necessarily a problem. So to talk a little bit also when we talk about risk here, and I know there's a lot of background before I get to the demos and everything that I will show you as well, but we have the type of risks. We have what we call user risk or workload risk. So workload is a user that's not a user. So think of it like a service account. So workload identities, when you go in cloud, you have quite a lot of these. So here we're talking about risk that identity has been compromised. So this is a state of that identity. It is not an action. So I can give you an example. For example, you get an MFA prompt on your device and you've done nothing. So you go there, so like, why am I being prompted for MFA? So you say, this is not me. In that case, that is going to mark the user risk on your account as high, because obviously somebody's trying to attack your account. And so that changes the status of your account. On the other hand, we have sign-in risk. This is not the risk for you as a user. This is the risk associated with what you're trying to do. So you're trying to sign into an application and we think it is not authorized by you, for example. Now, we also have detection types, and this is important that I mentioned, so real-time detection. These are the things that happen, especially associated with sign-in risk, where when you sign in, we see things that shouldn't, that look suspicious, but also we have, and this is actually a big part of it, offline detections. This is basically calculated on a schedule every couple of hours. We evaluate information about user, etc., and that may change your risk status as well. We classify the risk levels as no risk, low, medium, and high, and that you can then use in your conditional access policy to write rules around it. So when we look at the risk detections, real-time risks is things like unfamiliar sign-in properties, anonymous IP addresses, etc. So think, for example, if I were you to use a Tor browser that gives me an anonymous IP address, that will be a real-time risk that will be used when I'm signing in, could affect a specific response. Whereas some of the things that are offline would be things like leaked credentials, for example, password spray attacks. That's more stuff happening against your tenant. You have some of the anonymous user activity. All these things are things that get calculated offline, etc. So the other thing I want to talk about is Defender for Identity. And so I mentioned that I was going to talk about how you address an on-premise scenario and how you protect, rather than being purely in the cloud, how you deal with the on-prem one. And the first thing I want to show you, this is a very busy slide, but actually it's quite an important slide. Because what we have here, we call this the attack kill chain, but you can also, if you remove all the Microsoft products from this slide, then you would get what we call the attack chain. So an attack chain in information security concepts is really the idea where you start on the left, where you have an attack is started, and then you have on the right, where basically data is stolen from the environment. And the point of this slide is that there is a lot of stuff that happens in between. So for example, it starts with a phishing email, and say, for example, that phishing email is successful, then you'll have and so the protection against phishing emails would come from Defender for Office. Now, say something actually makes it through, then you have the protection from Entra ID coming in, and then you'll get the identity protection coming in, and you have the Defender for Endpoint. And so you have every step along the way, there's different technologies and products that can defend you. And it's one of the things we see phishing is a very, very important avenue in order to compromise your environment. But a successful phishing attack does not necessarily have to mean that your whole company is compromised. So that's kind of the point here, that you have each potential thing that happens, there's still other tools that protect you. And I've had customers say, well, why do I have to use risk-based conditional access? I already have access through, I already have, for example, compliant devices through Intune. And so that should be enough. And the point is here not that Intune and be a compliant devices managed through Intune and Defender is not good. It is just that it is one element, but you need to look at the whole thing holistically, start to finish, and then you'll see that there's different areas that Defender for Endpoint and Intune are not going to protect you against. And so this is where, and this is why I put that slide up here, is like you have the whole potential from somebody attempting to attack to exfiltrating data from your environment. That's just the thing, in this case, the damage they did. That there's a lot of different places and a lot of different opportunities that you can stop that. And you can see all the way on the right here, I have Defender for Identity. And Defender for Identity is a little bit, I mean, it comes as part of identity protection, the way it's licensed. But when we're looking at the whole environment, we have Entra ID, of course, is your whole cloud environment. And everything that happens in the cloud, we already spoke about, well, not everything that happens here. But how do you get for example, signals from on-prem? And that's where then the Defender for Identity comes into the picture. So Defender for Identity involves the installation of a sensor. So the installation is not very difficult. I mean, it's literally next, and then a sign in. But you need to install it on every domain controller in your environment, because it is basically a sensor that is collecting and looking at what's happening on those domain controllers. You also need to install it on your ADFS servers. So you need to install it in those components that handle authentication in your environment. And when we say it's a sensor, it is basically, it collects telemetry, it collects data, it collects information about things that are potentially bad and may, in some cases, take action. Now, we call it Microsoft Defender for Identity because it does work together with or larger Defender XDR product, which is the extended detection and response, which is where also your Defender for Endpoint comes in, etc., where you have all this different information that's feeding into the same system. And how does that, what does that look like? I mean, you have the installation of Defender for Identity is kind of trivial, and then it feeds in information. And what does that look like in kind of an example scenario here? And once, so say, for example, here we have a user, an Entra ID user, and this user has a particular score in Microsoft Defender XDR, an identity score. So you kind of rank things, and in this case, everything looks good. But then there comes the attacker, and the attacker manages to compromise a user, and the user risk of this user is increased too high. Now, so this is everything we've been talking about so far. So that increases the score, and that has certain responses. Now, the response that we normally would do is then force the user to re-authenticate with MFA, for example, which then triggers the risk to be reset, and you see the identity score goes back down. Now, how about, this is all fine in the cloud. How about in an on-prem environment? Say, for example, here we have an environment where we have an on-prem Active Directory. We have Entra Connect basically synchronizing accounts from on-prem to the cloud, membership, etc. And then you have, because we have the MDI sensor installed on ADFS and on all our domain controllers, basically we also get information fed in Defender XDR. And in this case, when we have an attacker starting to compromise thing, again, this gets detected. This triggers XDR in this case, or Defender in response. Basically, now looks and will start looking to block that account, block sign-in for that account, and that information will then be synchronized back up into Entra ID, and the account is disabled. In this scenario, then the user would go on-prem and reset their password, and that will trigger then all the risk statuses of that account to be reset, and we're back to where we were. And so Defender for Identity, just purely by installing that sensor, we basically enable multiple different authentication, multiple different automation actions to happen to provide protection, and all that information then feeds into the overall Defender product as well. So when I look, one of the things to be aware of when we're looking at MDI in this context is Microsoft Defender for Identity needs to be installed on each domain controller. The sensor also needs to be installed on ADFS. This collects signals and sends them to Defender, and then we use Defender's capability to automate a response. And that really is the extent of my presentation. So now we go to the hopefully more fun part and start actually.
Ward, if you can hear me, we have lost audio.
Yes, it's. I need to share a new screen. Good.
Okay, it has come up. All good.
Yes, so now that one has come back. Okay, very good. So now you can see here an Entra portal, and so this is this is a pretty empty environment that I set up. So it has users in it, but I don't have any particular policies yet configured. So, and I'd like to show them to you and see how you would go about and do this. So, so if I go under identity protection here on the left, so the easiest way you can turn on the risk-based conditional access is by just turning on the user risk policy and the sign-in policy. And if you go here, it basically tells you, we recommend you migrate to conditional access, because indeed, everything you can do here, you can do through conditional access policies. And typically, we prefer to do conditional access policy because you have more fine-grained controls. But effectively, if you were to look at this, you specify which users, you specify the risk, and in case of user risk, we typically recommend you select high. That's what you would select. And then the control you want to put on here is actually, in most cases, just require a password change. So you allow access, but you're going to say you're going to access as long as you change your password. So that's a very typical recommended way you do it. You enable it, and basically you have this enabled in your environment. But obviously, we've been talking about conditional access policy, and we're going to do this through conditional access because it's a little bit cleverer in a sense and gives us a lot more control. And again, look into this environment here. I don't have any policies really configured yet beyond some default ones that I've been playing with. And if you're starting from nothing, I would suggest you look at the templates, because the templates is going to help you set up a policy from the start without making too many mistakes. But we're going to create a policy from scratch here. And the first thing is basically, let's try to replicate exactly the same user risk policy. Right. And again, basically one says all users. Now it's going to tell you here as well, don't lock yourself out. You may want to exclude people. You could do that, but one of the things I really want to warn you against, because I've seen that happen too many times, is that then companies start excluding their admin people, their IT admin people, and those are really the last people you want to exclude. So I would keep it as all users. You need to specify the resources. So this is the other one, this is implied, but here you need to specify, and just specify all applications. And then you look at the conditions. And here again, I cannot stress this enough. Conditions basically control when this policy takes effect. So when we talk about user policy, I want this policy to take effect when the user risk is high. Do not set any other policies, any other conditions. If I set a sign-in risk policy as well, then both the sign-in risk and the user risk must meet those conditions before the policy takes effect. That is not necessarily what you want. So don't confuse conditions with the rules that a user has to meet. These are the rules that the policy has to meet to take effect. So don't put the more conditions you set, the less often your policy is going to kick in. And then the controls we have typically here will require a password change, and we grant access. And so select this one, and this is effectively looks exactly the same as the built-in one that you quickly turn on, but you have the option here to turn this on as report only, which I recommend you do for probably about a month, so that you can see what the impact is of this policy, and you can see how that would work in your environment. And so basically you create that policy, and now you have a risk-based policy in your environment. So when we deal with user risk, we typically set a threshold of high. Now, when we're looking at sign-in risk, let's do sign-in risk policy. Again, we do the same thing. We select all users. We're going to select all applications. And then the condition here, I'm doing sign-in risk. For sign-in risk, we typically recommend this kicks in for medium and high. So again, here, the previous one has a choice medium or higher. Here you have to select them. I do both medium and high because I want to have it cover both. If you want to have different rules that apply, then you could go and create a separate policy for it. And here, typically, you would require multi-factor authentication, for example. Now, because we're in conditional access policies here, you have more control, and you can take this quite a bit further with what you want to do. Similarly, say, for example, rather than forcing people to do multi-factor authentication, you could say, well, actually, we're going to do different type of controls. For example, I want to use different type of sign-in frequencies, etc. You want to so you'll have different type of controls and different type of settings you can use as part of this policy. Now, again, if I do the more standard one and follow the standard pattern, that's basically what this one would look like. And I have this as a report-only policy for now, so that you can see what the impact is of that policy in your environment. So my recommendation is, when you create risk-based policies, to create quite wide and encompassing policies. You can have, in particular situations, policies for particular applications that just block it for application B if the risk is high, or start putting conditions around rules around what rather than just doing MFA. For example, if you go to controls here, right, you have sorry, I'm looking at the wrong one. Grant, select, I want a particular authentication strength. So say, for example, you can log in, but it needs to be phishing resistant, for example. So you have particular controls that you can do with your conditional access that makes it stricter. Now, to just give you an idea of some other things, so here I have a different environment that is not as empty. So this is obviously, we always have a bunch of fake companies that we use. We have, for example, Contoso and Fabricam, and the other one is Woodgrove. And so this is an environment. The main reason I'm showing to you this is because my other test environment doesn't get enough activity. You can't really see what identity protection is doing. So if you go to protection and identity protection, this is an environment where it's all members of the engineering team, and we use this mainly to demonstrate things. But you can start seeing information about, in this case, particular risk detections that have been detected and what the response has been for these things. So you can then start seeing responses. You can start seeing the potential attacks that have been blocked. So you start seeing more information. And so the other thing, while I'm at it as well, I want to show you from the same environment is, for example, and here I'm into the Defender portal. So Defender is security.microsoft.com, and looking at the identity here, basically I've just looked at information coming from the Microsoft Defender for Identity, for example. And you can see that there's quite a lot of signals there from a while back. Again, one of the challenges we sometimes have is in these demos environments is that we can't really try to hack our own demo environments in order to create faulty traffic. So sometimes some of the environments that I specifically gets done so that we get some things to show. So this is, that's why it's all around the same time period in October and November. But you can see there's a bunch of different incidents that have been reported that show up, that have been discovered by our identity infrastructure that can trigger particular responses, etc. So this stuff then shows up. The information that's collected by Defender for Identity will actually show up in the Defender portals. Now, one last thing I want to show as well, because this is, we've announced at Ignite that within the conditional access policies, we were launching something called managed conditional access policies. And if you go into this particular environment, you can see here that this one has a little tab, and it says there's 2 policies that have been active. You see managed policies, and you can see here in the list as well. There's quite an extensive list of conditional access policies. Now, a lot of them are demo policies, as you can imagine. But those ones says Microsoft Manage, and these are policies that are created by Microsoft that we are implementing in a way to force companies to have better practices when it comes to securing their environment. Because one of the things I mentioned earlier is like when we started enabling security defaults, we found that most customers don't turn them off. So customers may not go through the process of turning on the security, the stronger security, but at the same time, if we turn them on for them, they don't turn it off either. So they kind of, sometimes it's not their first priority, and we kind of forcing this a little bit on them. But it's not a bad idea, it's not a bad thing that we're doing this, because it ultimately increases the security of your environment. And so in these cases, then you see these policies will start showing up in tenants that are licensed, where you have at least P1 licenses for all your users, etc. So there's a couple of conditions that need to be in place. And then you'll start seeing these policies appear. Now, these policies, for example, multi-factor authentication for the risky sign-ins, this is very similar to the policy I just created, right? It does pretty much the same thing, but you can see here that this policy, you can't really edit much. You can see here the conditions, and this is configured by us following best practice and what we recommend you do. So it applies to all cloud apps, it applies to all users, and require multi-factor authentication. You can then start doing some editing and exclude some users for it. And you also have the option of the policy is going to be set to report only. So if you don't do anything after 90 days, report only becomes turned on. But you can stop that if you don't want to use that. But obviously, what we really want to see is that ultimately we get to a position where pretty much all users have multi-factor authentication enabled. You have all your admins. For example, here we have a policy. This is the other one that's being created, that all the admin users require multi-factor authentication when they're logging in to protect your environment. And so because we are, I wouldn't necessarily call it being impatient, but we want more people to implement this, we're actually starting to include these as automatic policies that you can then start disabling if you don't need them. Very good. So that's the main bulk of my demo that I wanted to show. So let's see if there's any specific questions that have been reported. Otherwise, we can all give you about 15 minutes back and enjoy the rest of your day. So thank you very much for joining us today for this session. I hope it was interesting. Please leave us some feedback. We're planning to organize more sessions in the new year. We have quite a lot of different topics we want to talk about. So planning events around identity governance. We're planning events around our new SSE capability, but also talking about things like passwordless, talk about more about some of the other security products in the portfolio. Thank you very much.